Yup, 16-bit.
Range of number that I can use. For example, I say INT x. Right, INT x. So x equal to right.
10,000. What's that? 50,000.
Hey, the last row can see or not? So where is this? Where is this?
That's X. Whoever say why kill yourself right now, wrong.
Sorry? X got 10,000, right? Yes. So when you print X, right? You will see 10,000, right?
Yup.
Okay? Because I put INTX, right?
Yes.
Now I put an X equal to 50,000. I print X. What is my number?
50? Is it 50? It's a trick
Right
question.
now,
10,000. 10,000 too.
10,000, right?
Uh-huh.
I print X, 10,000. No
Uh-huh.
problem.
Uh-huh.
You're right.
Yup.
Okay?
Invalid.
X is 50,000. I print X. What is my number?
10,000. Error.
50,000?
10.
50,000? Yeah?
This is a executable program.
Alright. If you use any of the PC, if you use Python,
Uh-huh.
if you use C++,
Java.
or integer of 32,
Uh-huh.
you have this X equal to 50, print 50,000, no problem.
Okay.
But in microcontroller, use INT16. Typically, INT16 means 16 bits. You never get 50,000. You get negative values.
Okay.
Right.
I think too big already.
Okay, let me explain to you why.
Too big.
Too big to fail.
It's out. It's
Have
60
a
bit.
calculator.
Oh, never bring.
Give me calculator also never use.
Never bring sure.
Why?
Right. So when you do INTX, right? When you print this, you got 10,000, right? You do this, you print 50x equal to 50,000. You print x, I can tell you will never get into 50,000. All right. That is for microcontroller because just now I mentioned it's a 16-bit, right? Yeah. INT. In any programming, when you put INT microcontroller itself, it means that the number range from negative to positive. So the range of number I can show. There's a lot of things to show for x is from minus 327,682 plus 327,665.
5. Why 5 specifically?
65536. Yeah.
Okay.
Who's showing up gang signs?
2 of power of 16
Hey.
is 6553. 65536.
How you calculate?
65536 2 out of 16, right?
Oh yeah. 65536. Yeah. Uh-huh.
So if I do this unsigned,
Unsigned.
right? Please take note, this one when you do programming and all that, sometimes your data will. How come I got negative data? How come this is not the data I want? Because you must take note that when you declare INT, the number of X range from minus 32,000 to positive 32,000. Alright, because it's a sign value. You know what is a sign value? Sign value means that you got negative value and positive value.
So plus minus.
Yes. That means you got minus and plus.
Freaking head right now.
Understand? Sign value. Unsigned value means only positive number. Understand? Unsigned means there's no sign, no positive or negative sign. So the range will be always positive. When I put this, the range will be from 0 to 65535. That's a range of number I can represent. Alright? Understand? Okay, later on I can write a program and show you if I use the characters. Characters are 8 bits. 8 bit itself, 2 to the power 8, the number that I can have is 256. But 0 I must count. So I use unsigned characters, unsigned char. The range of number I can have is 0 to 255. But I just put characters, it's from minus 128 to positive 127. Understand? Let me explain again. In microcontroller, very important about the variable that you're declaring. Very important. Alright. If you use unsigned characters, you can show all the positive numbers. But you don't put unsigned, you just put int, you will have negative numbers. And it depends on number of bits you reserve in the memory. int usually is a 16-bit, but today is a 32 bits. Right. Character char is an 8-bit. It's an 8-bit. So use 8-bit, that means you only have 255 or 256 numbers, or what we call patterns, to represent. Alright? Okay? Alright, don't worry, I'll come to more detail about this.
Next question. Next question.
Even a simple quiz, but my quiz is always a lot of concept behind. So please pay attention.
So complex,
So complicated, sir.
There's a lot of concept behind. Okay, we go to the next question. Alright, we'll go to the next question itself. Okay, what is the purpose of variable? Just now talk about variables, right? Store data. Alright, when you declare characters, the char x, you basically create a variable called x. Just now when you see I put int x, right? So basically what I do is I create a, yes, why are you accepting standing up? Huh? Come forward. Alright, when you do intx, basically you create a variable called x. Right, so variable x is meant for you to store data. Right, for you to store a number. For you to store the status. When you say store status, basically the number, whether it's 1 or 0 means status, means number. It's not to do performing calculation, later on we'll talk about that. It's not to display information, it's to store number. Okay, go to the next question. Last two questions.
Let's go.
I love logic gates, bro. Logic gates are like one of my favorite subjects in DA.
Bro, my song Shobi, bro.
Shobi, I love Shobi.
Shobi, bro.
Shobi and show.
Shobi not sure.
Shobi, give me show time.
Oh, this is sure.
This one is tricky.
Alright, what does operator? Okay, the double N, in C programming, the double N got meaning. It means and. How about or?
What's the symbol for that?
What's the or symbol? The two line, yeah? How about not?
Minus?
Explanation mark, huh?
Or explanation?
Alright, take note, huh? Or is explanation mark. Alright, explanation mark itself. Sorry, or not is explanation mark. Or is a two line. It's a two line. Okay? In the keyboard itself, you see a two line basically on the right side of the keyboard.
Life is tough.
Life is tough.
Go to the next quiz. Next question. Alright.
This too easy. Hey Jay, you wish one something. Hey, you the oh number oh some.
Can't tell me nothing.
The Lord always my Lord.
Look, man. Look, always repeat, man. Void, loop. Sure, void loop. Void set up.
Alright, what is the purpose of a loop?
Void loop.
Alright. It is to repeat a set of instruction. Looping. That is called looping itself. In programming, sometimes we call the term called looping.
Void loop.
Okay? Alright, so the last question itself. What is the role of a function in a programming? You will learn about function later on. I'll create a lot of functions.
So going to be at the function.
Oh.
Right, function itself.
Oi! Something wrong.
Right, groups. A set of instructions for reusability. That means you want to reuse the instructions.
Next time press faster, bro.
Drop for me.
Okay, I'm going to show you this result. Right, typically, okay, you pay attention over here. Can you pay attention? Alright, so this is something I use online, but it will not be seen really clearly later on, because online, when I try integer itself, because online processing, the integer variable is very large. Alright, so I only can use char. A char is an 8-bit character itself. So you see that when I put there char x,
Character X.
alright, char x itself, when x is 100, it show me 100, no problems.
Okay.
But when mine says x is 500, because it's more than 8-bit range, alright, there's some error there, overflow. Yes, I know, I purposely let it overflow. But the number becomes negative 12. Okay? So if I want a negative 1, alright. Okay, the question is, if let's say I put there 128, right, what is the number for x? Can you tell me?
1.
What's the number for x?
Negative 1 to 8.
For error, this one for error itself.
Negative 1 to 8.
No error, sorry. You see when I put 1 to 8, right? What did it give me?
Negative 1 to 8.
Minus 1 to 8. Is there error? Is there error?
No, I don't see no errors.
Let me ask you right now. Your programs, later on you probably say I want to save memory. I just want to use a character, char, char. So when you put an X, somehow when you counter, you want to add the number of people walking through the gate. Right, so you plus, plus, plus. So from 1 plus to 2 plus to 3 until plus 1 to 7. The next time we plus 1 to 8, suddenly is display minus 1 to 8. Is it correct? Right, it's not correct because there's an error there. Right, so if let's say you do a counter, you never minus, right? You never minus, so in other words, remember just now I talked about unsigned.
Yeah.
When I talk about unsigned itself,
Plus minus.
alright, so when I do an unsigned, you see that now I got 1 to 8. You understand?
Yep.
Alright, understand this is programming, especially in microcontrollers. You need to take note. The register itself sometimes only give you 16 bits. Alright, in computers, yes, you can go up to 64 bits using 64 to represent variables. But in a microcontroller, sometimes we don't have that luxury because it's very, very small. Okay? Alright, so who is the judge?
I'm taking it.
Next question. Any more?
No one. Finish. Last question. Press faster next time, bro.
Okay. A lot of people got it wrong. So, alright, 3 of you later on, or put on the top 5. Put on the top 5. Alright, top 5 come and collect something from me later on. Okay? Alright, we'll go to the topic today. Yes, we may run out of time. So, alright. One is a microcontroller, history of microcontroller. Probably I'll give you a quick one. Application, just now we covered a bit some. Alright. This one you see in the quiz. We may not have time to cover today. I'll cover on Friday itself. Especially pay attention to ALU, because last time we learned how to even design our own ALU.
Wait, you can?
Yes, you do your own designing out of the ALU itself. Alright. How controller make a decision. So basically, alright. So, even the pacemaker, you know the pacemaker that people install in the heart, near the heart itself, right? Because they have irregular heartbeats, so you need a pacemaker, right, to regulate the heartbeat itself. If you talk about 30 years ago, it's very expensive, but today a lot of people install a pacemaker because the cost is very low, and they are using microcontroller. It's low power. Right, it's a very low power microcontroller itself. So basically, a microcontroller will have sensor. You will have an I/O port itself. The I/O port will control the sensor, read the data from sensor, and the sensor actually what they give. What does the sensor give? The sensor only gives the resistance values, and from resistance value, you put a voltage, you get the current flow of the signal. From there, you know what is the voltage level. Once you know the voltage level itself, you can convert into number using the analog to digital converter.
Analog to ADC.
Alright, so once you have the number itself, your program will do a comparing, matching, and collect data and send out. So basically, it's very straightforward if you look at it in a very overview. Alright, so what we have problem over here itself, I have the ECG pacemaker. So the ECG itself, you put those probe, alright, the electrode itself on the muscle. Right, what will happen is when you look at the oscilloscope, you see signal forming, and this signal forming itself is actually the current, and from there you can measure the voltage. Correct? From current you can measure the voltage, right? Because current, you put a resistor, you got a voltage, right? Okay, so once you got a voltage, you can use ADC, give you number. Then use the microcontroller processing to convert with some meaningful data. Then you perform what you want to do.
Go
Right, pump the heart, send signal,
right,
etc.
Go down, go bit down.
Okay, so besides use in the pacemaker, you use for TV, automotive, everything. today's there's a lot of microprocessor. Even those headset that you're wearing, some of the headset says that I have noise cancellation, right? How does the noise cancellation works? Basically, there's a processor, read the signal, alright, filter off those noise, alright, minimize it, or sometimes do a negative setting so that you have noise cancellation in the headset. So we also have microprocessor. So it has been used in even a key. Alright, for example, today you have digital lock. Those at the door itself install digital lock. Those are microprocessor, microcontroller. Okay, this one is not in the text. Basically, I think it's good that you know about this. Alright, what is this graph? Last time, when I start to learn about microprocessor itself, is at this era here.
1980s.
Right, and the number of resistor used. You all know resistor, right? You all know the BC547. Use a BC547 right, in your practical AA.
Yep.
BC547, what is BC547's resistor? PMP or NPM? 555. 555 is a timer. 555 is a timer itself. Alright, you use BC547. Alright, NPN transistor. One transistor, that big. But today's, you have how many transistors in your handphone?
A lot, bro.
Million of transistors. Why? Because the transistor is so small in terms of micron. Micron. What is micron? Micrometer.
Micrometer.
What is micrometer? Very small.
Very small.
Very, very small. So,
No
alright.
way.
So I see someone do selfie behind. Wi-Fi. Nice photos.
Micro penis.
Alright, this one will tell you, right, number of core means that today's, okay, what do you mean by number of core? Multi-core itself. Multi-core, today's you have a lot of multi-core in your laptop. One IC chip, one processor, you got so probably 5 or 8, sorry, probably 8 processor itself. One CPU got 8 processor. Alright,
Wow.
so that is why called multi-core. Last time, one CPU, one processor. That is in the 80s time when I start to learn this. One CPU, one processor. Today's, you open a laptop, one CPU, 8 processor. So the power that it can do is fantastic. Of course, the power you use a lot, getting hotter and hotter, right? So this is what I mean by that. I'll give you this slide later on. I'll compile more and I'll give you right in the WhatsApp group. Okay. This is in your notes. I purposely put over here, although I don't like this picture. All right. Just now we talk about microcontrollers. It has CPU. All right. It has ALU. It has I/O port. It has register. All right. So I mentioned register. Right. I mentioned register is a memory, right? Remember just now I mentioned register and memory?
Yep.
Okay. We'll come to that later on. Register is a memory, but it's meant for very high speed processing. ALU, I/O, GPIO, memory. Register is an internal memory for the processor chip. External memory for the processor is RAM, flash, ROM, etc. Come, help me to connect lesson. Alright, so basically, microcontroller system consists of microcontroller and all the memories. Right, it has all the memories here. I/O port allow system to integrate with outside external device. Communication port, alright, with other devices such as sensor, actuators, timer, ADC. This picture probably I brought out. I will explain more detail in that when we probably next Friday on Friday itself. Okay. You will learn Arduino, right, for this module. As I mentioned, when you go to I think IoT, right, you'll learn about Raspberry Pi, right? You'll learn about Raspberry Pi. I think you'll learn Raspberry Pi right now. Right, the STM32 and our chip, MSP. These are all the processor chip, microcontroller processor chip that we have, but our focus will be on Arduino. This just give you an idea. Okay. I purposely put these pictures, it's not in your notes, but this is what the IC chip use in Arduino. It's an AVR STM chip itself. And can you pay close attention here? You have a CPU inside there, consists of the ALU, consists of the register inside there. Alright, consists of the control itself. Then after that, you have all these so-called external peripherals in the processor chip. You have flash memory, EEPROM, alright, EEPROM NIF, another new memory is here. Right, you have non-voltage management, programming, power management, and clocks. These are all peripherals for the Arduino. And many, we did not use a lot of features. In your book course here, we also never use a lot of things that, for example, watchdog timer. So, you see something interesting at watchdog. What is watchdog? I'll explain that. Use ADC, external interrupt. EXINT is external interrupt. I'll explain that later on. Timer 1, timer 2. Alright. Universal, synchronous, asynchronous. Alright. Receiver transmitter. Alright. Internal reference. What is this meant for? You have op-amp, right?
Yep.
Op-amp is how many input? 2 input, right? So you have one input is a reference voltage. The other input is an external input. That's how you get ADC. Then you have the SPI. Alright, synchronous peripherals interface. Alright, you have other parts. Okay, can you tell me? Right, if you can even write, I'll dismiss you.
Now?
Right.
Like now?
Yes. What is the purpose of watchdog?
Watch what? Watchdog?
Watchdog.
What is the purpose of watchdog?
Guard duty.
What is the purpose of watchdog?
Guard duty.
To monitor the CPU. Monitor something. Monitor the CPU.
How does it work? How does it work?
How does it monitor the CPU?
You tell me, yeah, monitor CPU, but how does it work?
How does it monitor the CPU? Oh, sleep around, right?
Yes.
Bro, say. You already got answer. How does it work?
How does it work? Give me a layman example. Give me a layman example. Explain it in layman terms.
Oh, got the CPU, right? Yeah, so?
So, what is the purpose? Alright. How does a watchdog works over here? You get it right, you can go.
Google, bro.
Google will tell you a bit. Alright. This one I learned from my so-called my master when he teach me this one. Okay, what does the dog do? What does the dog do?
Dog.
Alright, either a pet or guard, right?
Yeah.
Alright, so when you see the watchdog, usually they talk about criminal, right?
Yeah.
So imagine is that there's this burglar itself go to the compound. Alright. In order to keep the watchdog keep quiet, what does it? Alright, burglar do? Throw something to eat, right?
Yeah.
Alright, throw something to eat, right? Okay, to distract it, throw something to eat.
Yep.
So the burglar itself want to do something. Rob the house. First thing itself, throw some bone or a food to the dog to eat, right?
Yep. Sure.
So the dog will finish ready.
Yep. Sure.
But if let's say burglar have hard time to open the door, what happens? The dog will not be busy, because nothing to do, right? So you try and bark. Alright. So in order to keep the dog busy at what it is, throw another thing for it to eat. And then so that the burglar can do something. So that's the purpose of the watchdog. So in the program term, in the microprocessor term itself, anything, if you want your system to be reliable, you must activate this watchdog. That means you know your programs, maybe you execute every 10 seconds or every half an hour, you throw something to the dog to reset. So when you throw something to the dog, reset itself, the dog will not bark, right?
Yep.
You just keep quiet. If they say half an hour later, the dog nothing to eat, right? What happened? You bark. So this is the purpose of watchdog in the microprocessor. You execute your programs. At one point of time, you throw something to it. Says that, okay, I'm alive. Alright, you don't buzz, you don't set alarm. So continue. Alright, continue. Until the watchdog is not being received any information, you start to alarm, you start to trigger. Why we want to do that is to prevent your system getting hanged. Alright, your system will not hang if let's say you activate this watchdog. Because sometimes let's say your system hang, right? You get stuck. Then what to do? Imagine microprocessor is used to control lift. And the microprocessors there get hanged. The passengers in the lift they stay halfway. What happened?
Stop. Why didn't he stop?
Alright, the lift will just hang there. So you need a watchdog to trigger it, because if let's say it did not have a signal coming, it will reset, probably go back to the ground floor.
Wow.
If not, it just hang there. Alright, so that is the purpose of having a watchdog in the processor. Understand?
Yes.
Understand?
Yep.
Alright, don't have. Okay, 4:30 you can dismiss.